Good morning. So we are going to be talking today about Lewis dot structures. Lewis dot structures are going to take the place of some of the things we've been learning. So I am going to try to get this lecture done in about 20 minutes. If I go a little bit too fast, please slow it down. That's it. Please take a periodic table out. You're going to need this today and every day for the next while. So we're going to draw the electron shell models for fluorine. So here's fluorine right here. And we're just going to start ourselves off with regular fluorine, which is a neutral atom. And that means that since it's neutral, the number of protons equal the number of electrons because there's no charge on this. So we're going to draw the shell model for it. This is shell level 1, shell level 2. And you can see that fluorine is on shell number 2 or row number 2. That's row number 1. So we would draw fluorine. We could draw our 2 shells. So there's our 2 shells. And then we're going to take a look at how many protons do we have. We have 9 protons. So there's our 9 protons, which means we have 9 electrons. And now we just have to fill in our 9 electrons. So let me change the color on that. And 1, 2, and then 1, 2, 3, 4, 5, 6, 7. Because 2 plus 7 equals 9. And so that is our 9 electrons. So that's this is the shell model for fluorine. Now let's do the shell model for the fluorine ion. So the fluorine ion's a little bit different. It's still fluorine. So we have 9 protons, but now you see this little minus sign here. That minus means we have 1 extra electron. All right, if it was a -2, we would have 2 extra electrons. A -3 would be 3 extra electrons. So this has a -1, which means we have 1 extra electron. And so we're going to have 10 electrons. And then very quickly, remember the charge equals the protons minus the electrons. Well, if the charge is a -1 and the protons equals 9, right? 9 minus what gives you a -1? We'll subtract 9 from both sides. 1 minus 1 minus a 9 equals -10. -10 equals a minus electron. And then what are we going to do? But just get rid of those minus signs by multiplying both sides. So 10 equals the number of electrons. However you want to do it, mathematically, or just figuring it out and going, well, if you have 9 protons and there's a minus, you get that 1 extra. So now, here we go. So how would we draw this? Well, we're going to put our F minus right in the middle so that we know what we're drawing about. It's still 2 shells, but now we have how many electrons? Now we have 10 electrons. So 2 electrons, there's 1, there's 2, and then 1, 2, 3, 4, 5, 6, 7, and then 1 more. So then there's 1, 2, 3, 4, 5, 6, 7, and then 8, that last one. So this would be the model for the fluoride ion. Stop it if you'd like. I'm going to move on. So now we're going to do sodium. I don't want to clear all this out. So let me clear this out though. So let me clear all this out. All right. Now let me pause the video while we wait. Okay, I'll get better at this as we go. So at this juncture, we're going to be working with sodium. Whoa, exactly. We'll be working with sodium. So what do we have for sodium? Sodium is going to be right here. So sodium has 11 protons, all right? So sodium has 11 protons, and since we're neutral, it has 11 electrons because there's no charge. So if we're going to draw it, we can see that sodium is going to be in the first box on the 3rd row. So we're going to have 3 shells. 1, 2, 3. And we have 11 electrons, and we know that the electrons come on in. We have 1, 2 on the first, 1, 2 on the first row, and then we have 1, 2, 3, 4, 5, 6, 7, 8 on the second row. So I have to do 1, 2. I'm just going to do it like this because I know 2, 4, 6, 8, right? And then on the third row, I just have 1. Boom. So there's my 1 outside electron. It's on the very outside, so that's my valence, and that's where we lie on that one. So let's take a look, and let's do our next one. So sodium ion, it's going to be right here. This is our sodium ion. So let's take a look at our sodium ion. Our sodium ion, here we go again. We're going to be working with element number 11, which means we have 11 protons, right? And how many electrons do we have? Well, this plus sign means that you have one more plus, or one more proton than you have electron. And if you have 11 protons, because sodium always has 11 protons, and if you have one extra proton, then you must have 10 electrons. And again, I can show you that here. The charge equals the protons minus the electrons. The charge equals a +1. The protons equals 11. So 11 minus what gives you a +1? I don't think I have to go through the math on that one. 11 minus what equals a +1? The answer is 10. So now what we're going to do is we have Na+. We're still on the third shell. All right, there's 2, 1, sorry. There's 2, and then here's our third shell. So what we have now, let's draw in our electrons. We have 10 electrons. There's 1, 2. Let's make those a little bit smaller. 1, 2. Then we have 3, 4, 5, 6, 7, 8, 9, 10, because we have 10 electrons right here, right? 10 electrons, and that's it. We're done with our electrons. So what does that mean? Well, what that means is if there's no electron in a shell, we just get rid of that shell. So we'll just get rid of this shell here. And this would be the drawing for our sodium ion. All right. So now what we want to do, let's take it to the next level. All right. And let's draw radium. Radium is down here, element number 88. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 shells on radium. I'll put it right here. So here's radium. There's 1, 2, 3, 4. Oh my gosh. 5. Oh, this one's gonna be a big one. 6. I'm running out of space. 7. Whew! And we only have to put in 88 of those. We only have to put in 88 electrons. So 1, 2, and then 2 on the second, because there's 1, 2, and then I have 8 here. 1, 2, 3, 4, 5, 6, 7, 8. And I have 8 on the next one. 1, 2, 3. Kids, this is just going to be a mess. So the activity today keeps us from having to do some crazy giant electron dot structure. And I'm going to take you into that right now. So what I want to do is take you through this process right here. So we're going to be talking now about Lewis dot structures. And the Lewis dot structures are going to keep us from having to draw all of these shells. All right. Now, the point of the Lewis dot structure is so that we can find out what the valence or outermost shell looks like. Because in chemistry, we don't care about anything except for the outer shell. So these inner shells right here, they don't ever react. It's the outer shell's electrons that react. So we care about the valence, which means the outermost electrons. So the Lewis structures, we're going to draw only the valence electrons. And the electrons that are valence are the outermost electrons. So let me just take you through the valence. This is column number 1, column number 2, column number 3, 4, 5, 6, 7, and 8. These guys in here, we are not going to use them at all. So we're going to get rid of these right here. we're only going to be using 1, 2, 3, 4, 5, 6, 7, those columns. So valence electrons are the outermost electrons. So hydrogen has 1 valence. Lithium has 1. Sodium 1. All of these, all the way down, have 1 valence electrons. This column here, all of these, have 2 valence electrons. This group here, these all have 3 and 4, 5, 6, 7, and starting at neon, 8. So these all have 8. Helium is a special one. Helium only has 2, because it only has 2 protons. Of course, it cannot have 8 electrons, only 2. But it goes 1, 2, 3, 4, 5, 6, 7, 8. So I could say, how many valence electrons does arsenic have? And you would say 5, because it's in the 5th column. How many valence electrons does chlorine have? How many valence electrons does rubidium have? So those are the questions that you're going to be asked. So it goes straight across 1, 2, 3, 4, 5, 6, 7, 8, 9, or to 8, sorry. So for example, how are we going to do this? First, you're going to count the columns to determine the number of valence electrons. Again, 1, 2, 3, 4, 5, 6, 7, 8. Next, you're going to draw the electrons, and you're going to draw the electrons clockwise. So I'm going to start here with lithium. So lithium has 1 valence electron, and we're going to start right up here. There's our 1 valence electron. Beryllium has 2 valence electrons. Now it says you must draw them clockwise. So you're going to start here. And if you're looking at a clock, that's clockwise. So 1, 2, good. We're going to skip all of these. Remember, these don't count. So we're going to come to boron. How many valence electrons for boron? That's right, 3. All right, and we would draw them in 1, 2, 3. And then carbon. Carbon has 4 valence electrons. 1, 2, 3, 4 valence electrons. Nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. You can see now there's 2 of them up here. Okay. Oxygen has 6. I'm always going to put a curly Q up there. 1, 2, 3, 4, 5, 6. Fluorine has 7. 1, 2, 3, 4, 5, 6, 7. And then neon, which I'll just put right here because I'm running out of room. 1, 2, 3, 4, 5, 6, 7, and 8. And that would be the number of valence electrons for each one of these. Now, oxygens would look exactly the same as sulfur. So if you drew sulfur, sulfur would look like this. 1, 2, 3, 4, 5, 6. Notice the sulfur looks just like the oxygen because there's 6 valence electrons. Next, if you're working with an anion, which is a negatively charged, you're working with an anion, for example, fluorine has 7 valence electrons, but since there's a minus here, that adds 1 electron. So now fluorine with a minus charge, it has 8 valence electrons. Let's look at nitrogen. Nitrogen is a 3 minus. So how many valence electrons does nitrogen with a 3 minus have? Well, nitrogen normally has 5, but there's 3 more electrons, which means that one also would have 8. I could do this one down here. We could do this polonium. Polonium normally has 6, but if I put a polonium 2 minus, that would mean polonium 2 minus has 10, right? So this is how we work the valence. Mr. P, how would we work with the lithiums? Well, lithium, okay, lithium would have a +1 charge. So anything that says subtract valence electrons that have cations. So if you have a lithium with a plus charge, normal lithiums would have normal lithiums would have 1 valence electron, right? But what are we going to do? We're going to take 1 away, and we're going to go back. And we're going to have to go back all the way over there. Since it's element number 3, it's going to have the same as element number 2. So lithium would have 2 valence electrons. Remember, we said that this one has 2 and then 8. All right? Now, if you're like, Pepik, woo, let's look at magnesium. Magnesium would be a +2. Magnesium would normally have 2 valence electrons, but since there's a 2+ charge, we're going to get rid of 2 electrons. We're going to get rid of 1, get rid of 2, which means now it's going to be the same as this one here. It would have 8. I'll take you through that process in just a little bit. So what we're going to do, let's draw the valence. Let's draw the Lewis dot structure for radium. All right? And then you'll see and you'll be like, oh my gosh, Pepik, seriously, that's it? I'll be like, yeah, that's it. So here's radium right here. So remember, 1, 2, 3, 4, 5, 6, 7, and 8. 2 for that one. And these would be our valence electrons. So how would you draw it for radium? This is what your assignment is today. Determine how many, well, let's draw the Lewis structure for radium. So here it is. There's radium. And how many valence electrons does radium have? 2. 1, 2. And that's your answer. What? That's your answer. You're welcome. Determine the number of protons and electrons. Well, now we're going back and reviewing things we've already done. So how many protons does radium have? 88. How many electrons does radium have? 88. How many valence shells are there? 1, 2, 3, 4, 5, 6, 7. Mr. Pepik, there's so many terms. I know, you'll get these things. There's 7 shells. Oh, wait, oh my gosh, I totally messed it up. That's the shells. So how many shells does radium have? Radium has 7 shells. Oh my gosh, I can't rewind the video. So hopefully you guys all just heard my correction. 7 shells. How many valence electrons are there? We'd already done that. There's 2. 2 valence electrons. So the new things we're learning are valence electrons. We already know protons, we already know electrons, and we already know shells. So now we're going to put all of these ideas together. But this is our new picture. And that keeps us from having to put all of these circles, 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 until we get to our last orbital on radium, where we'd have said, okay, we've got 2 electrons, and then that would be it. So this saves us from having to draw all of those inner electrons, okay? And that's the whole point of Lewis structures, to save the chemists time, because they do not want to waste time. So here's our activity today. All right, I'm hoping I'm keeping this lecture under 20 minutes or somewhere close to it. I'm probably going to jump up to 30, but that's how it works. So what we're going to do is we're going to practice doing the Lewis dot structures, but we're going to fill everything else in. So here we go. Sodium, how many protons? There's sodium right here. How many protons does sodium have? Good, sodium has 11. How many total electrons does sodium have? Yep, equal numbers. There's going to be 11. How many valence electrons? Remember, valence electrons, those are the outermost electrons, right? So these are the valence electrons. And this is going to be 8. But remember, helium has just 2 valence because it only has 2 electrons. So how many valence electrons does sodium have? 1. How many shells does sodium have? 1, 2, 3 shells. So it would look like, I'm not going to draw it. So then what would the Lewis dot structure look like for sodium? It would be an Na, and then it would have 1 valence electron. There it is, done. All right, Mr. P, I think I got this. Okay, well, let's see. Now let's try Na+, which is right here. So Na+ has how many protons? That's right, there are 11. How many total electrons are there? Don't say 11 because this has a plus charge right here. Remember, this means there's 1 extra proton. Remember, the protons are positive, the electrons are negative. So if there's 1 extra proton, we must only have 10 electrons. Well, if we have 1 less electron, and this was sodium, this was Na, and we had shell 1, shell 2, and shell 3. But if we only have 10 electrons now, we don't have a 3rd shell. all of the electrons are in here because we only have 10, which means we only have, that means that this sodium comes through. That means we only have 2 shells. And how many valence electrons? Well, this shell won't be there anymore. All right? That shell disappears. So that means the outer shell has how many electrons? That's right. The outer valence now has 8 electrons because it went from 11 down to 10, right? So it would have 8. Oh, that's a big number. 8 valence electrons. And then let's draw it. It would be Na plus would be our symbol, Na plus, and then would be 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's take a look at the next one, chlorine. Let's look at chlorine next. And now for this next one, we are going to be doing and working with chlorine. Okay, so let's look at chlorine. But this isn't chlorine, this is chlorine with a minus charge. This is going to be chloride, chloride. So let's take a look. There's the chlorine. So how many protons? 17. Good. How many total electrons? Now, since there's a minus charge, that means there's 1 more electron than protons. So if you have 17 protons, you must have 18 total electrons. And then let's look at our valence. So right here, we have 7, but it's going to be chloride, which means it gets 1 extra electron, and we're going to go and we're going to have 8. What's the shell? We're going to be on shell number 3. And if you're like, Mr. Pepik, there's just so much to remember, I totally get it. So try and come up with some tricks to remember what's a shell, right? What are some of these other things? So let me draw chloride out for you. Chloride with a minus. 8 valence electrons, 2, 3, 4, 5, 6, 7, 8. Okay, so I just paused the video quickly just so I didn't waste your time, and I drew this structure for you. And so this is chlorine with just a Cl. And you'll see there's 17 electrons. 2 plus 8 is 10, plus 7 is 17. But we're doing chloride, which means that chloride requires 1 more electron. And that would be the 18th electron. So that minus charge right there is that last electron, which means now chlorine has 18 total electrons, but on the outside, chlorine has 2, 4, 6, 8, and that's where the 8 comes in. And now for this next one, we're going to take a look at aluminum. Notice, oh my goodness, notice that this aluminum has a 3 plus charge on it, okay? And that 3 plus charge means that there are, think about it, more or less protons. It's a plus charge, protons are plus. That's right, there's gonna be 3 more plus charges on that. So here's aluminum, all right? So aluminum has how many protons? 13. How many total electrons? Well, there's 3 more protons than there are electrons. So that means there's only gonna be 10 electrons because aluminum used to have 13, 1, 2, 3, but it lost those last electrons, right? Because aluminum started off with 13 electrons. So here are all of aluminum's electrons. And what happened to aluminum's electrons? Aluminum lost those electrons. How? It doesn't matter. But that little plus means there's 3 less. So that means that aluminum no longer has 13 electrons. Aluminum now has 10 electrons, right? 10 total electrons. So how many valence electrons? Well, if we take a look, we can see that this right here is now the new outer shell for aluminum, right? Because this shell, there's no electrons on it anymore. So how many valence electrons, outer electrons, does aluminum have? Aluminum has 8 outer electrons. And how many shells? Well, a lot of people are going to miss this question. How many shells does aluminum ion have? Not 3, kids, because aluminum ion, that does not exist out here. Those electrons don't exist. Since those electrons don't exist, that means that level doesn't exist. So let's just take a look here. And we have 2 shells. And now let's draw this aluminum. We're going to put aluminum with a 3 plus. How many valence electrons? 8. Maybe I'll just make that a little bigger. Maybe I'll make it easier for me. Let's see if I can do it. 1, yep, 2, 3, 4, 5, 6, 7, 8. There's aluminum with its final Lewis dot structure. Now I'm going to have to make a move on this one. Okay, so now what we're going to do is we're going to take a quick look at this sulfur. This is a sulfur right here. Now there are 2 electrons on it called sulfide. So let's just take a quick look. Now remember, this was the number of, I'm going to shrink the screen down for you kids. Okay, thanks. So now let's take a look down here at the bottom, and we're going to see our sulfur. Okay, so sulfur has 2 minus charge, which means there are more or less electrons. Oh, I'm off by 1. Hold on. Okay, so we're going to take a quick look, and let's look at sulfur. Sulfur has a 2 minus charge. That means there's 2 extra electrons. Sulfur normally has how many protons? Good, 16. How many total electrons does sulfur have? Well, normally sulfur would have 16, but there's 2 extra ones. So now sulfur has 18 electrons. How many valence electrons does sulfur have? Well, normally sulfur has 6 valence electrons, right? But now sulfur is going to get 2 more. So if I draw this out, right, and we look at it, sulfur's got all these electrons coming out, right? This is what sulfur normally has. So sulfur normally has that many electrons, 16, right? If you go through, you would count and say, yep, I should probably put it underneath the element. There's 16, but there's 2 extra. So we're going to give them 2 extra, which means now sulfur has how many electrons that are in the valence? That's right, sulfur is going to have 8 valence electrons, because this is the outer shell. This whole thing is the outer shell, right? And there's 8 of them in there. How many shells are there? 1, 2, 3. 3 shells. And then what's the Lewis dot structure? Well, here's our compound right here. It's S2 minus. So let's take a quick look at the Lewis dot structure. So we'd have S2 minus. We have 8 electrons in the outer shell, right? Which means we want to put 8 electrons in. 1, 2, 3, 4, 5, 6, 7, 8. And there it is. So I'm going to skip that last one. I'm going to let you guys go. I will be here to field questions. Please, when you finish the video, talk to me and let me know if you have any problems. If you're like, man, I don't get that one thing, go back and listen to my words. There are several places where you need to work. Number 1 is learning. What's a proton? Then, what's an electron? What's a shell? And now we have a new word, valence, right? Electrons. Energy levels, or not energy levels, but the shells going down. Valence electrons, protons, all of those words you have to start feeling very comfortable with. So again, I'm going to let you go. Hopefully the video was helpful.